Hello student, today I am going to teach you the clique clustering algorithm. The clique clustering algorithm stands for clustering in quest. This technique is a density based clustering technique that uses grid technology for forming the clusters. This technique was proposed by the Agrawal, Gateway, Gunpolis, Knopfler and Raghavan in 1998. In this technique, we divide our n-dimensional data space into equal partitions. It means all the n-dimension are divided into equal length interval. In this, after doing partitioning, we divide our data space into non-overlapping rectangular units or grids. These grids are of equal size, and after that we distribute our data in this grid-like space, and after distributing the data we set a criteria that decide the region as dense or rare based on the basis of number of elements. If a unit is having more than defined limit of data element, then it is considered as dense, otherwise it is considered as rare. The after combining all the dense region or connecting dense regions, we find out the clusters in the subspace, or we can say that a cluster is the maximal set of connected dense unit within the subspace. First we shall divide our space into grids of equal size, and we shall check out which grids are having more than threshold limit of data element. All the data grids which are having more than defined threshold data elements will be considered as dense. For example, if our threshold is 5, then all the grid which are having more than 5 or equals to 5 data element would be considered as dense, and rest of the grids which are having less than 5 data elements would be considered as rare data element. In clique technique, we also use the property of the a priori algorithm. But before designing this property, we should define something in formal languages as unit or grid. Unit after forming a grid structure on the space, each rectangular unit is called a unit or grid. In the grid-like subspace, a single grid or a grid-like structure is called the unit. And what is dense unit? All the units which are having a fraction of data points contained in it that exceeds a certain threshold are called as dense grid. The grid having more than a certain number of data elements are considered as dense, otherwise rare. A cluster is defined as the maximal set of connected dense unit. After connecting the dense region together, we find out the cluster in that area. Cluster in that area. In clique technique, we also use the define a variable of n dimension. The represented of an n-dimensional variable is represented like this. Suppose there is a variable a which is of d-dimensional, then the a would be represented with help of a1, a2 up to ad tuples. There are d tuples, and each one will be projected in d dimensions, as a1 in one dimension, a2 in two second dimension, a3 in, and so on, ad in dth dimensions. In this way, a d-dimensional data A would be represented in d-dimensional space. After that, we should know about the minimal description of the cluster. But before that, the basic thing that we should know is that it uses also the a priori property. The a priori property I'm going to take says that k-dimensional unit is dense, then so its projection in the k minus 1th dimensional space. It says that if certain kth dimensional unit is dense, then in k minus 1th dimension, or its projection in k minus 1th dimension should also be a dense. We can simplify it as that if a data set is dense in kth dimension, then it should also be dense in k minus 1th projection dimension also. To explain it better, I want to give you an example. For example, we want to calculate the number of students who have 75% marks or more than 75% marks during their BTech in every semesters. Suppose we have 10 students and there are 8 semesters in BTech. Then there would be 8 mark sheets for 10 students each, and it means there would be 80 mark sheets. So instead of checking all these 80 mark sheets, we shall find out that the number of students who have got 75% or more than 75% marks in their first semester marks. Some of the students may who have not got 75% in marks in first semester would not qualify for the second sem. So we shall filter out, suppose there are 2 students, then we shall remove out 2 cross 8, means 16 mark sheet out of it, and we shall consider only 5 next 5 mark sheet of second sem for the student who have qualified the criteria. Or we can say that for being dense in the kth dimension, we should be that the projection should be dense in the k minus 1th dimension. So likewise, we are reducing our resulting space in each iterations by filtering these data. So this way, a priori property is used that only data that is dense in the k minus 1th projection could be dense in the kth dimension. To give you an example, here I am giving you an example. Here there is a 3-dimensional data: salary, age, and vacation. Suppose we are not taking all these 3 together and we are just taking 2 dimensions, salary and age, and we are projecting our data in 2-dimensional, and the distribution of data element is as shown in the figure. Here the gray region shows the dense grids, and this is the projection of our data in salary and age, just 2-dimensional out of 3, and this is the projection space in 2-dimensional of a 3-dimensional data. The actual data is 3-dimensional, but we are projecting it in 2D dimensions, and this is the clustering region. And suppose now we are taking the third dimension, vacation and age, then the clustering projection is as shown in the diagram. Here we are seeing that the k minus 1th or 2-dimensional projection in salary and age is different from the projection of the same data in vacation and age. These two are very different, and if we want to know the 3-dimensional projection, then what we do, we overlap these two, we intersect these two, and the region that is common in both of them would be considered as the 3-dimensional projection. In this way, we are just calculating 2-dimensional project, and we can calculate the higher dimensional projection without actually drawing the 3-dimensional data space. In this way, we are using the a priori property, and we are using the 2-dimensional projection to find out the 3-dimensional projections. This is the concept same as used in the a priori. So this technique is density based plus using the grid-like structure plus using the a priori property. And what are the advantages? The advantages are like that key that we can, they are, so this is the main advantages, and in this way it is very much efficient in calculating the higher dimensional data. Suppose I'm going to take you the another slide, the minimal descriptions. I have defined you earlier that I'm taking you back to the minimal descriptions of the clusters. The minimal descriptions of the cluster C produced by the above procedure is the minimum possible union of hyperrectangular regions. Here, we are showing the same diagram, but note down that A union B is the minimum cluster description of the shaded region, but C union D union E is non-minimal cluster description of the same region. Why so? Because actually they are covering the same area, but read out the definition once again. Is the minimum possible union of hyper-rectangular region. First of all, the region should be rectangular. And here C, D, and E is also rectangular, satisfying the criteria. But the problem is that the minimum number of rectangle required to represents the area. We should have the least number of repeated area or covered area. In A union B, the overlapped region is minimum. But in case of C union D union E, the union of E is extra because E is covering more area twice than the overlapping region covered in A union B. The triangle is used, but to represent that area, the minimum covered area is larger in C union D union E, so this is not the minimal one. So minimal description area is the set of the triangle which are used and which have minimum overlapped region. So the A union B satisfy the criteria, but C union D union does not satisfy the criteria. So on basis of this, I am going to take you the slide. Right. The strength of the and weakness of the CLIQUE algorithm. First of its strengths, it automatically finds the subspace of the highest dimensionality such that high density data cluster exists in those space. I have told you just after calculating the two-dimensional data space projections, we were able to calculate the high dimensional data, three-dimensional data by overlapping the two-dimensional data space together. So we did not need any three-dimensional projection space, and we calculated it with the help of lower dimensional space data. It is quite efficient and it scales linearly with the size of input and has good scalability as the number of dimensions in the data increases. As we know in real world, we have limitation in representing the data in more than three-dimensional space. So this technique, by taking by taking one by one dimension or two or three dimension in a set, we can divide our n-dimensional data space into different parts components, and after overlapping all these together we can project the cluster and find out the cluster in a higher dimension. So this can be scaled up to higher dimension very efficiently, and it does not depend on the number of dimension, and it is scaled linearly. It is insensitive to the order of record in input and does not presume some canonical data distribution. In it doesn't matter in which order we are taking a component or which sequence we are taking. So it does not depend on the sequence that which two dimensions we are taking together. So it is very easy to use, and it's not problem to take any dimensions at starting or later. The weakness is that the it lacks some little bit of accuracy. In terms, suppose the threshold criteria is the criteria which we have decided. Suppose we have decided that the unit is dense or only if it has 5 data element. And suppose some grids are having four data element, and we have rejected them. And if in terms of n dimension we have lost a lot of data, that could have been significant if we have taken the better threshold. In this way, we could lose some amount of information, but it is not that significant. So CLIQUE is the very convenient clustering technique which uses the a priori property in which n-dimensional data clustering can be done very efficiently, and it is very much scalable. So it is very easy. So thanks to all of you for joining.